Now, let's discuss step-by-step working mechanism of an OHP. The first one is light source illuminates the transparency sheet. The OHP has a high intensity lamp, halogen or LED positioned beneath a flat glass surface. A transparency sheet or acetate sheet with written or printed content is placed on this surface. The light passes through the transparency, illuminating the text or image. For example, a teacher places a math equation transparency on the OHP and it gets illuminated for projection. The next point is Fresnel lens focuses the light. Directly above the lamp is a Fresnel lens, a special type of flat, thin lens. This lens helps to evenly distribute and direct the light upwards. It ensures that light spreads evenly across the transparency for a clear projection. For example, without the Fresnel lens, the projected image may appear blurry or unevenly lit. The next point is reflection by a mirror and projection lens. The light carrying the image from the transparency travels upwards to a tilted mirror at the top of the OHP. This mirror redirects the light forward toward a projection screen or wall. A projection lens in front of the mirror magnifies and sharpens the image before it is projected. For example, if the mirror or lens is misaligned, the image may appear distorted or out of the focus. The next point is image appears on the screen. The light carrying the transparency content is now displayed on a wall or screen. The size of the projected image depends on the distance between the OHP and the screen. The focus knob on the OHP helps adjust sharpness and clarity. For example, a history teacher can adjust the focus knob to make a map projections sharper for students. Now let's discuss the educational applications of overhead projectors. Overhead projectors were once a staple in classrooms, lecture halls, and training centers due to their ease of use, affordability, and interactive nature. Despite the rise of digital projectors, OHPs are still used in traditional and resource-limited educational environments. The first point is mathematics and problem-solving demonstration. How it's used? Teachers write math equations, formulas, and problem-solving steps on transparency sheets. Live demonstrations of algebra, geometry, and calculus are possible. For example, a math teacher solves a quadratic equation step by step on a transparency sheet while students follow along. In a geometry class, teachers draw and measure angles on transparencies, making concepts clearer. The next point is science and biology diagrams and how it's used. Biology, chemistry, and physics teachers use OHPs to display and annotate scientific diagrams. Labeled anatomical structures, chemical reactions, and circuit diagrams can be shown clearly. For example, a biology teacher projects a diagram of the human heart and labels each part by explaining its function. Another example, a chemistry teacher overlays multiple transparencies to show the step-by-step process of balancing chemical equations. Now, the next point is history and geography map projections. How it's used? Teacher use historical maps and geography charts to explain concepts like border changes, climate zones, and migration patterns. Multiple transparency layers can be stacked to show changes over time. For example, a history professor overlays different maps to illustrate how Europe's political boundaries changed after World War II. A geography teacher projects a climate zone map and overlays another sheet showing temperature variations. The next point is sentence structuring and language learning and how it's used. Teachers write sentence structures, grammar rules, and vocabulary words on transparencies. Students can correct mistakes in real time by writing directly on the projector. For example, an English teacher highlights common grammar mistakes by marking incorrect sentences directly on the transparency. Another example, a French teacher writes verbs in different tenses and asks students to fill in the correct form interactively. The next point is business and economics data presentation and how it's used. Business and economics professor use OHPs to display financial charts, supply demand graphs, and case studies. Overlays allow for trend analysis and comparison. For example, an economics professor overlays a demand curve on a supply curve to explain market equilibrium. Another example, a business studies lecturer projects a financial report and annotates important trends in company revenue. The next point is step-by-step art and design instructions. How it's used. Art and design teacher use OHPs to demonstrate drawing techniques, color mixing and pattern designs. Transparent layers can be used for tracing and modifying images. For example, an art teacher shows step by step how to draw a portrait, allowing students to follow along. Another example, a fashion design instructor overlays different fabric patterns to illustrate how they combine in dressmaking. The next point is classroom discussion and brainstorming sessions. And how it's used. Teachers encourage students to write ideas on transparencies and project them for discussion. Used in brainstorming, debates and group projects. For example, a teacher asks students to write their thoughts on a topic and projects different responses for a classroom discussion. Another example, a teacher in a creative writing class displays students' story outlines and edits them collaboratively. The next point is training and skill development workshops and how it's used. OHPs are used in teacher training, skill development and vocational education. Step-by-step guidance for technical drawings, mechanical diagrams and blueprints is displayed. For example, a vocational training instructor teaches students how to read engineering blueprints by projecting detailed drawings. Another example, a culinary school instructor shows knife cutting techniques with illustrated guides. The next point is special education and learning support and how it's used. OHPs are effective for students with learning disabilities as they provide a visual, hands-on learning method. Larger text and diagrams make lessons accessible for students with visual impairments. For example, a special education teacher projects large, clear letters for students with reading difficulties. Another example, a teacher working with dyslexia students use color overlays on transparencies to improve reading comprehension. Now, the next point is traditional classroom notes and lecture presentations and how it's used. Teachers use pre-prepared notes or handwritten explanations to present lectures efficiently. Useful for schools without access to digital projectors or smart boards. For example, a college professor writes lecture notes in advance on transparencies, making the lesson structured and time efficient. A substitute teacher quickly present content using pre-existing transparencies without needing a digital setup. Overhead projectors remains valuable educational tools, especially in budget-conscious schools, hands-on learning environments, and special education programs. They offer interactive teaching, real-time writing, and cost-effective presentation options. Thank you, everyone.